I'm going to talk a little bit about dilutions, serial dilutions. If you have a solution of a particular concentration and you want to make a more diluted one from that one, we call it a stock solution. What do? And there are two methods, one that you have probably come across and the other one that you might not have come across, which is the dilution factor, which I'm going to cover now. So what happens if you have a solution that is too concentrated and you need to dilute it before you use it? Let's say that the signal you're getting in your user spectrometer is too high, or you want to make a series of solutions starting from that one. So let's say, for example, that you have your 6 molar solution that you have prepared before, and you want to make a 2 molar solution. And let's say that you want to make a liter of it. So you can calculate what we call a dilution factor. And dilution factor is the concentration we have, in this case is 6 molar, divided by the concentration we are aiming for. In this case, 2 molar. So 6 divided by 2 is 3. So we have a 3 times dilution factor. This 6 molar stock solution will need to be diluted 3 times to make a new solution which is 2 molar instead of 6. So what does this dilution factor 3 means? Well, it means that your 6 molar solution needs to be diluted 3 times to reach a 2 molar solution. So how much of that stock solution would you need, 6 molar, to give you your 2 molar solution? Well, you will need to divide actually the 1000 milliliters you actually need by 3. That is the dilution factor, and that gives you what, 333.33 milliliters. So you will take 333.33 milliliters of the 6 molar solution, and you would top up to a liter to make the new solution. So that's how you use the dilution factor. You divide the volume of the solution, and that tells you how much you are going to need from that solution, and then you top up to a liter with solvent, in this case with water. I mentioned the dilution factor because you will see it in some cases, and for example, some people are more comfortable using dilution factors, and sometimes in some biochemistry experiments you will see the use of dilution factors. Another way you have to work out how much of a particular solution you need, a stock solution, to make another solution is by using this formula: C1 times V1 equals C2 times V2. So C1 is the stock solution, what the concentration is. V1 is how much of that stock solution you need to make your the solution you're aiming for. You don't know that, because if you did, you wouldn't need to use the formula. C2 is the concentration of the solution you are aiming for, and V2 is how much of that concentration you want to make, typically the size of the volumetric flask. So 25 milliliters or 50 or 100 or 250, how much are you going to do? Are you going to make in total? So if we go back to our original example that we had before, we had a solution which was 6 molar, and we are going to make a solution which is 2 molar, and we want to make 1 liter. Fair enough. So the concentration of the stock solution is 6. We need a certain volume of that solution, which we don't know how much it is. We're going to make a solution which is 2 molar concentrated, and we're going to make 1 liter, or if you prefer to keep it coherent with the previous one, 1000 milliliters. And if you work that out, it gives you the volume that you need to take, as in the previous case, because it's the same solution, is 333.33. So you would take your 1 liter volumetric flask, you would put your 333 milliliters of stock solution, and you would complete up to the mark with water. So in both cases, you end up with the same answer because you are, after all, making the same solution, a 2 molar solution. You just use 2 different methods. So just pick whichever one works better for you. They both give you the same results and they both work equally well if you're comfortable using it. So this is all from me about this topic. We've covered quite a lot of ground. We've looked at chemical equations, what the symbols in a chemical equation tells us, the subscripts and the superscripts, the concept of moles, the molecular mass, how to convert between grams and moles, and vice versa. The concept of Avogadro's number, that is just a tool, a number that we use because it's convenient, the concept of the mole, to convert between grams, which is what you weigh in the lab, and moles, which is what you normally work when you are working with a chemical equation and when you're working in the desk. We've also looked at concepts around solubility and what happens for something to dissolve, and a few units of concentration that you will come across. Some of them you have already come across, others they will come in future modules and future years and your future careers. And finally, a brief look at something that you have already done in the past, hopefully you remember, which is doing dilutions. What happens if you have a concentrated solution and you want to make a more diluted one by using that one? So this is all from me. I hope it was useful. And if you have any questions, just drop me an email. And thank you very much for watching.